Okay, I think we are over the time, 16:01. So we will start right now. And hello everyone who's joined today in our Zoom meeting. My name is Matis, and I am from a company called TestDev Lab. So TestDev Lab, who doesn't know what TestDev Lab is and does? A few words about the company. So we are a quality assurance company, which is based in Europe, Latvia. We have been around for 10 years, and over this time we have gained quite some experience with our own framework, test framework creation, test automation tool development, and also quite early we started also to do performance testing. And there are now around 300 and a bit more engineers in our company. So we are working globally, and more than 4 billion people use the products that we test daily. And about this webinar, so this webinar is going to cover the topic about mobile app performance testing. And the focus here will be on two main platforms, Android and iOS, and also a bit around it. So the Zoom meeting will be recorded. So for everyone to catch up later, you will get a link to the recording, and the questions and answers that will be open after the presentations. So don't miss the chance to ask the questions to our experts. And so the speakers today, you see here Maris, Tauno, and me, Matis. So hi, Maris. Hi, Tauno. So Maris is iOS developer in TestDev Lab with many years of development experience in different, creation of different apps, and also performance testing them, especially on mobile, on iOS. And Tauno is our senior Android developer, and he will talk about the tooling and practices that can be used to benchmark Android software. And me, I'm senior automation engineer, so I've worked on some custom, test automatization frameworks several years, and I have both like manual and automated mobile performance testing experience. And yeah, as I said, the agenda. So we hope to squeeze in within 1 hour, but overall, the three main things is going to be, firstly, Maris is going to tell you about iOS and the approaches of using like white box testing and a bit of black box testing approaches for iOS. And then, secondly, Tauno is going to tell about the same on Android, with more focus on black box testing perspective, and introduce you with some most common tools that we use into our everyday testing. And also, I'm going to talk about performance tests in general, a bit distant from the platforms. It's going to be about third-party approaches of battery and network testing, and also doing competitive analysis and benchmarking of your software or hardware. So we're going to switch the controls to Maris and start with iOS. So Maris, the stage is yours.
Hey guys. So, okay, let's start then. I hope that everyone can hear me. So, Apple provides plenty of useful tools for us to test and measure the performance of the application in many different ways. So from our experience, I would like to point out three main utilities which can help you diagnose performance issues in white box testing. So let's start with the first one, the Xcode. So let's imagine that we are developing an application. We are continuously adding new features to this application and dreaming about its next big release. But developers tend to forget that while developing new features, it's easy to accidentally introduce performance issues like unexpected CPU work or a memory leak, and not even notice these issues until the app is released and the customer starts to complain, like that song list scrolling isn't smooth enough. To monitor the application high-level performance, developers even do not need to switch to another software. Xcode has really good debug graphs right in front of us in the Xcode Navigator. These graphs can be really helpful to point out performance issues early in the development stage. In my experience, developers tend to forget about them or even do not know that these graphs exist. In the provided examples, you can automatically notice two things. First, the CPU graph contains a suspicious spike. And second, the memory graph shows that the memory usage is always growing and is never released. Both these graphs indicate that there could be a problem in the code. CPU spikes can often mean that the app is using unnecessary processing power, and that could cause the battery to heat up and start draining more quickly. Unreleased memory could mean that the app will get slower and slower. For example, new screens will start opening slowly and with a delay. And eventually the operating system may just terminate your application because of too much memory consumption. By continuously monitoring these graphs, developers have a higher chance to notice a recently introduced unexpected CPU work or a memory leak or potential problems and fix them. From my experience, I really recommend to monitor these graphs not only before the releases, but also after finishing each new code implementation, just to verify that everything is working correctly. By the way, there are more than 2 graphs available in Xcode. So let's talk about the simulators. Device simulators also provide multiple debugging tools, but this time let's talk about one specific tool, the color blended layer detection. Let's look at the image on the left side. Here you can see an application which displays a list of Imagine Dragons songs together with some additional information like images, labels, and colored views. The issue here was that on the lower end devices, when user tried to scroll, the list is freezing and that makes the app feel really slow. Cause of that was the view color blending. In simple words, the operating system needs to do additional work to blend the color of the views, which are more or less transparent, together with the color of the views behind them. When the color blended layer detection is activated on the simulator, the screen gets covered with green and red color, like you can see on the second image. Green color means that the view is opaque and everything is good. But if the view is covered with red, it means that some part of this view is transparent and the system needs additional work to do to blend it. These kind of views can often cause a frame rate to drop, especially if the screen contains a scrollable list. In the current application, it resulted with a bad user experience while scrolling. And a bad user experience, as we know, can result with a 1-star reviews in the App Store. In our company, we have over 2,000 testing devices, including all lower-end iPhones and iPads. Because of that, our engineers managed to quickly discover the slow scroll issue, and with the help of the color blended layer detection, inform the developers about the possible cause of it, the red spots. So let's talk about these red spots on the screen. There are multiple ways of screen optimizations, but from my experience, I would point out the 3 main things. So first, try setting the same background color for the labels as it is for the views behind them. Second, don't use transparent images if possible. Try to use images with already background color in them. And third, try not to use views with reduced opacity. For this application, developers replaced the transparent images with the non-transparent versions and added background colors to the labels. And that already improved the performance quite a bit. You can activate the color blended layer detection for simulators from the debug menu like this. It's quite easy to do. And you can also activate it on the real devices through the Xcode debug menu while the device is connected to the Xcode and the application is running. Color blended layers are activated not only for the testing application, but for the whole device. That means that you can switch to other applications also to see if their developers have paid attention to improve the rendering. Here you can see your testing application on the left side and the Apple's calendar application on the right side, with the color blended layer detection switched on. As you can see, Apple can try to optimize the screen also because of those red spots in there. Okay, the second utility which I want to point out is the XC tests. XC test is a native Apple's testing framework which provides necessary functionality to write unit and user interface tests. I'm guessing that everyone who has written a few user interface tests for the iOS has also seen this specific test method for application launch performance, which gets automatically generated every time when a new test target is created. And if you have seen it, I can guess that you have also deleted it to make room for your own tests. But this test was generated on purpose to let you know that it's possible to test the app's performance straight from the Xcode. And you don't even need to switch to another tools or software to do that. Since Xcode 11, Apple provides multiple metrics to measure apps performance straight from the user interface tests, like CPU, memory, and storage usage. In our experience, these types of tests helps a lot for detecting regressions after adding new features. For example, catching a memory leak. When you create these performance tests, Xcode will record the test baseline results. Then each time the test is executed again, it will compare the new results with the baseline results to see if they matched. If they don't, test just fails, informing you that something isn't wrong. I want to mention that it's a best practice to run these kind of tests using the project's release configuration, and also disable all of the Xcode's runtime validations, screenshot grabbing, and code coverage for more precise measurements. Here is an example of a memory usage performance test, which tests for memory leaks just by opening and closing a new screen in the application. The baseline is already set, and the test passes successfully in this case, because the current test run returned a similar amount of the memory usage. But after doing some changes in the code, the story is different. The same test failed. It detected that the average memory usage now is by 49% higher than the baseline test result. This can indicate that there is a memory leak and the developer should take a more in-depth look at this scenario. Okay, and now I want to talk about the third utility, which I want to point out is the Xcode Instruments. The Instruments is Apple's main debug tool, which provides a lot of possible ways to deep dive into the application's runtime processes and get a lot of information out of it. For example, what is the CPU usage at any point in the application's runtime? What is the thermal state of the device while the application is running? What is the frames per second value while user tries to scroll a list in application, and more? There is a lot of predefined debugging templates, which can be used to debug the application. Each year, Apple provides new ones. It's definitely the best tool for analyzing the performance of applications. But while the graphs are really good and gives us much information about the current test run, it is quite hard to compare them between multiple test runs. In the current example, you can see only one test run. By working with different clients, our experienced engineers have created multiple automated scripts to get the raw data from the multiple test runs in the instruments and format them in a nice way so that the results could be comparable and easy to discuss with clients and see regressions or updates in performance. So if you are using this tool and want more readable data, contact us and our engineers can help you with that. And now let's talk about the black box testing. Apple prevents all ways of attaching the instruments to an App Store applications. Therefore, any tool which relies on the Xcode debugger cannot read any information from the system for the testing application. That's done for security reasons. But fortunately, Apple also provides their own on-device metrics of the application usage from the App Store application users. These metrics, which can be found in the Xcode organizer, provides insight about the app's performance. For example, what is the scrolling hit rate? Or in other words, is the scrolling smooth enough? These metrics are really useful to find out more about the performance status after each release. Unfortunately, without developers providing more context to these metrics manually, it's not possible to easily debug them. But at least you can see the overall performance of the application. And now about the key takeaways. First, as you already saw, there are multiple tools available to you to debug your application and look for potential problems with the performance straight from the Xcode. You don't even need to switch to another platforms. The more you will use them, the quicker you can eliminate the problems. So use them not only before releases, but also while developing the app. And second, Apple provides an easy way of creating a performance tests right inside the Xcode. So why not take the advantage of this feature and create at least one or few automated performance tests just to verify that the application works as expected and does not create any side effects. And if you need any help with that, you can contact us. Thank you. That's all from the iOS platform. Matis, you can now take over.
So I don't know how many of the audience know about these color blended layers, but in this slide I saw that, for instance, there are a lot of like red spots even after the optimization is done. So are those critical, or what do those red spots mean, and why are still there even after like you optimize the code?
Thanks, Matis, for the question. It's okay to see some red spots on the screen still after you are trying to optimize your screen. You need to avoid the dark red spots, like you can see in the small image before the optimization. The dark red color means that system needs to render more than one layer with the color behind those views. So it needs more process to do that. So, but if you see a pinkish red color, that's okay if you do not have any performance issues with the older devices with scrolling. This pinkish red color is there because of that view contains rounded corners, and those rounded corners are pretty small area where the operating system needs to blend the color of that view. So because of that, it does not take a lot of performance, as I mentioned, and we don't see any impact on the older devices. So that's fine if you do not have all screen green always. I hope that I answered the question.
Okay, thank you. I guess that explains some things, like, you know, a rule of thumb about those unit tests that also you don't need to aim at 100% coverage, as there are some things can be left. Okay, thank you, Maris. And the next speaker is Tauno. So, Tauno.
Hey, from my side as well. Sure.
Hope you're ready. Okay, now it's your turn.
Yep, perfect. So yeah, hi from my side as well. Thanks, Maris, for the iOS part. First, I'll be talking about black box performance testing on Android, and I'll specifically talk about the tool called Battery Historian that I found rather valuable throughout the years. Battery Historian, as the name implies, it's a tool to analyze the battery consumption impact of various applications, OS components, and hardware components as well. And it's a completely black box tool, meaning that there is nothing that needs to be integrated into the analyzed application or even the device that you are analyzing. You can analyze the historical battery consumption on any device without having to even connect it to anywhere. So it's a completely black box approach. And Battery Historian uses the historical system level logs generated on an Android device to show you a timeline of various aggregated statistics and events. It also highlights potential issues and metrics that have an adverse effect on the battery level. It's definitely not a tool that's part of your day-to-day development workflow, that's for sure. But it comes in handy whenever you need to investigate reports about high battery consumption from somebody. Let's cover some use cases that Battery Historian enables. For example, it's able to show an application's estimated power use on the device. So that's for any application. It's able to show the historical states of system components. For example, the screen on-off state, CPU usage, battery percentage, Wi-Fi radio state, mobile radio state and coverage, GPS usage, and so on and so on. So there's lots of data there. You can use it to analyze if an application uses resources when it shouldn't be using them, or it uses them too frequently. For example, you can detect if an application is doing some periodic background work when it shouldn't be doing it. For example, you analyze in the morning if the application was indeed polling for location during the night with the frequency that you wanted it to. And you can identify application bugs this way as well. It goes the other way as well. If you write some code that's supposed to do something in the background, then you can later check with battery history if your application was actually being waken up at the time when you thought it's being waken up. And one common use case where a developer would get use out of battery history is when, for example, you push out the new release to a wider internal audience. Let's say a project manager or a bunch of project managers or other teams inside your company. And then somebody sends you feedback that their battery is draining much, much faster than it used to do. And the description of these issues is usually rather vague. Something like, I had a full charge when I went to sleep, and now the battery is dead in the morning. So what's up with that? And you can't reproduce this issue. So because it always works on your machine, right? So what do? How do you start investigating this? You could fire up your code editor and start going through various places in your code based on just gut feeling and see if you maybe have a place where you're stuck maybe in a loop trying to retry some API requests to your backend that are failing, or maybe you failed to release a GPS lock in some specific use case related to location, and now you're constantly polling for location data, even when it's not really needed. I mean, who knows? You could definitely do that, but it's usually rather time consuming, and there's lots of guesswork involved as well in investigating it this way, since you can't reproduce it on your end in the first place. And here's where battery history comes into play. You can ask the person who reported the issue to get the bug report on their device. That's a term that Android calls the logs that you can gather from a device. So that's a zip file that the user can then send to you, and you can then take that zip file, either use it yourself or create your developers, and feed it into battery historian, and it will spit out a nice timeline of events that happened on the device and that might have an impact on the battery consumption during the last day or so. So the information and data that's included here is plentiful. You'll see exactly when the screen was on or off, when the GPS chip was on, when the CPU was sleeping, or when it was not sleeping, then what caused it to wake up, or which application caused it to wake up. You can see how good the mobile coverage was, when did the phone switch between Wi-Fi and mobile data, and so on and so on and so on. There's lots of information here, and the screenshot even doesn't cover all the potential metrics that you can add to this graphics or timelines. Yeah, and this kind of first level analysis helps you to rule out any device-specific conditions that might have caused high battery drain and narrow down the offending area. So it might be that your application isn't actually at fault and the cause for the battery drain. So battery historian can be used to rule out other causes. And here's an example of an area that I highlighted. And if you look at the black line that goes from the top left to the bottom right, then that's the battery percentage. I've highlighted an area of interest where there's something going on that drains the battery rather quickly just before the device is put to sleep for the night. So that's the area to the right of the highlighted area there, where really nothing is happening. And from here, we can quickly tell that some application was keeping the CPU active. It was holding a wake clock for a long time. It was keeping the Wi-Fi radio active, and it was transferring data as well. And if you hover your mouse over the area that you're interested in, then you can actually find out which app was responsible for these events. And in this specific case, I checked it out and I found that it was Google Photos. So you can guess that it was probably syncing pictures and videos that I took during the day. So that was the cause for that specific drop there in battery. But that's just a kind of scratching the surface of Battery Historian, as it can do so much more. For example, it can show you the data usage per application and show you the estimated power consumption per application as well, and other cool things as well. But just important positive parts are that the device that you analyze doesn't need to be connected, and you can use a device from somebody outside of your immediate development team. It has lots of historical data about everything that happens on a specific device. So there's lots of different data points, and you can use it to pinpoint causes for high battery drain that would be, I would say, impossible to determine otherwise. But there are also some things to be aware of. First, the statistics can be inaccurate or sometimes misleading, because it's not exact science, and all the analysis that Battery Historian shows is based on device logs. So these might be inaccurate in some cases. And the documentation about the meaning of different metrics is also basically non-existent. So quite often you have to check Battery Historian source code to see what some metrics actually mean or how they are gathered, or sometimes you need to check Android source code to see how the logs are generated in the first place that Battery Historian is analyzing. And thirdly, the bug reports are sometimes, like Battery Historian has a hard time analyzing these bug reports from some specific devices, because device manufacturers are making changes to how the logs are generated and to the format of the logs. So this might sometimes not be formatted in the way that Battery Historian expects. And before I forget, we have a test developed blog post about Battery Historian as well. The title is "How We Test Mobile Application Performance as a Third Party." Yeah, so check that out if you want to learn more about that. Let's talk about some black box testing approaches as well. Let's start with some memory usage, because memory usage is a hot topic. Why is memory usage testing and analysis worth a separate section, you might ask? That's because memory usage is a painful topic. At least it has been for me throughout the years. The total memory available to your application varies a lot across devices and OS versions as well. And how memory pressure is handled on different devices varies a lot as well. So we have a lot of different devices, Android devices specifically in Test Lab, that we use for testing. And trust me, your application might work just fine on most of them, but crash constantly with out-of-memory exceptions on other devices. And speaking of out-of-memory exceptions, you usually run into them only in production via crash reports from your real users, via your crash reporting service that you use. But the problem with this is that this never happens on your device, so you can't reproduce it. You can't really find out what happened. And B, even if you do get out-of-memory stack traces, then these are virtually always totally useless, because they don't actually say what's leaking memory, but instead they highlight a random memory allocation that occurred in your application that just happened to be the last drop in the bucket, so to say, that caused your application to run out of memory. And there are two tools that are mostly used to tackle that issue. So first, there's Leak Canary that can automatically detect memory leaks during development and QA phase, and also during production. And secondly, there's the memory profiler built into Android Studio that you can use during development. Start with Leak Canary. So Leak Canary is an extremely valuable tool for most Android applications, because most of them deal with memory issues sooner or later. And by default, it's able to automatically detect memory leaks of all Android components that have a life cycle, such as activities, fragments, views, etc. And with some additional setup, you can use Leak Canary to detect leaks of any objects you want. So if you have some heavy objects in your application, memory-wise, I mean, then you can configure Leak Canary to monitor these as well. And Leak Canary also supports tracking leaks in production now, which is really cool. In which case you have to integrate it with your logging service that you use or crash reporting service. And this way you will get automated reports about memory leaks that are happening to real live users, which is extremely helpful. And there's even more. It can even automatically fix some common memory leaks in OS versions and third-party libraries during runtime now. And by that, I mean that different Android versions have memory leaks, and different manufacturer customizations of Android have memory leaks, especially one manufacturer that I won't name, but everybody knows. And these leaks are counted towards your application's kind of memory bucket. So even if you are not leaking memory, you might be using either OS methods and APIs that are leaking memory, or you might be using a third-party library that is leaking memory, and the end users don't care. It's your application that is crashing. So Leak Canary has support for automatically fixing some of these leaks, or at least adding workarounds for them. And that's done automatically as well, which is, I'd say, rather useful. So Leak Canary in action. I have a quick demo-ish thing here, how Leak Canary works. I took Kickstarter's Android application, which is open source, and I added Leak Canary to it because Kickstarter wasn't using it for some reason. And Kickstarter's main screen is rather straightforward. It has 4 tabs. And here's what Leak Canary reports when you move from the first tab to the last, and then back again to the first tab. First, it shows that there is a new distinct leak happening just by switching tabs. And then it allows you to drill down into the details of the leak. And from here, it's able to automatically show you the shortest reference path from the garbage collector route to the leaking object. So you know exactly where the leak is happening. And in this specific case, the last tab that we saw earlier, that was supposed to destroy all references to all views that it was using, but it still keeps a reference to some layout objects. And Leak Canary is basically able to highlight the exact place where it thinks the leak is occurring. So you can quickly jump to your source code and fix the leak there. There's another tool as well, Android Studio Profiler. It's something that you developers are probably using rather frequently. But in addition to detecting memory leaks, like Leak Canary is doing, it's also useful in just optimizing your memory footprint, as you can use it to list the biggest items that are in memory, or just track memory allocations throughout time, and do other interesting things with it. The UI for it is rather simple, on the surface at least. It shows you a timeline of memory usage grouped by various types of memory. And here's an example of a view that shows constantly increasing memory pressure when using an application. This time I've cheated a bit, and I introduced a new activity leak into the same Kickstarter application myself to show just how it looks like if you have a huge activity leak in your application. And every time you navigate between screens, the previous screen is kept in memory and the total consumption increases constantly until it eventually runs out of memory. And once you run a heap dump, then the profiler will helpfully show you a list of all objects that are kept in memory. And it will also helpfully point out the potential memory leaks. These are the ones with the yellow exclamation mark there. It's similar to what Leak Canary is doing. And from here, you can drill down into individual objects, see their sizes, and see all objects that are referenced by these objects, and also see all the other objects that are referencing your leaking object and so on. So it's basically a surgical knife for finding out all details about memory usage of your application. Yeah, here are the things I want to highlight about white box memory testing. First, use tools that automatically report memory leaks. There's no real reason not to do that, and you will thank yourself in the future for doing so as well. I mean, trust me, I'm speaking from painful experience here. Secondly, monitor memory usage between application versions. If you ship a new version, then always be aware of the fact that how much memory it consumes compared to your previous ones or previous releases. This allows you to detect increased memory consumption early before it reaches your users. And lastly, be aware of your memory usage profile in general. By this, I mean that be aware about where your memory is going. If you know that the third-party library is consuming like 90% of your total memory footprint, then knowing this helps you to make more informed decisions about which libraries to use in the future. And if you talk about black box testing, so how would you test something when you maybe don't necessarily have access to the source code of the application, or you want to test the release version of an application because it works differently? Then how can you do that? Luckily, Android is not so restrictive as iOS is. For memory usage, there's command line tools that give you insight into the current state of memory consumption. For example, there's a dump.sys meminfo tool, and using that tool plus some like writing some scripts to monitor ADB output, it allows you to get the view rather similar to what we see inside the Android Studio. With this approach, you can analyze any application. So it doesn't matter if the app is debuggable or not, or if it comes from Google Play or it's your own application. Here are just some examples of the types of tests that we have done for our customers with these tools and scripts that we have written. So the example on the left is a competitive analysis of different applications running on the same device. So you can see how you are performing compared to your competitors. And the example on the right is a comparison of different automated test runs for the release version of a single application. And this allows you to verify if the memory consumption is stable across the same use case throughout different test runs. And here's another example of detecting leaking memory in an application in different use cases. And that's all done with the actual release binary, not the debug binary that you can debug with Android Studio. Because the release binary can behave differently than your debug binary in some cases. So it's useful to do some black box testing around that as well. And now let's talk about CPU usage testing. The story with black box CPU testing is really similar to what we just covered for memory testing. There are command line tools that can be used to gather statistics about CPU usage. And you can write scripts, again, to generate actionable reports from this data. And again, this is for any application on what's running on your device, and you aren't limited to your own application. And here are some examples about the potential results of this approach. Again, we've done some competitive comparisons of applications and their main competitors, looking at how they perform under different use cases, potentially in different devices or OS versions or vendors. And on the right, there's a graph showing the CPU usage across different tests for a single application. That's useful if you want to find out if you have any unexplained spikes in CPU usage. And the main takeaways I have for this is, first, Android provides lots of information about CPU and memory usage if you know where to look and how to use that information. Secondly, aggregate data from different sources to get a better understanding about the performance kind of overall picture. And look at the memory and CPU metrics across longer timelines as well. Don't just look at what's happening right now on your device, but let monitoring run for some minutes or hours or days and see if you can spot anything that shouldn't be there. And finally, automate performance testing as much as possible. From experience, I'd say that it's always worth to wire up all of these scripts and processes as part of your continuous integration pipeline or release process to spot any potential issues as early as possible and prevent these from reaching your customers and end users. Yeah, and I'll stop here and we'll let Matti speak as well. You can ask questions at the end of this talk and I'll do my best to answer them.
Thank you, Tauno. Actually, I was impatiently waiting to ask you one question right now, but of course others will just warm up with the questions and so on. So I was listening you saying that so these performance things on Android, the tests can be really automated, but as we know, it's not that easy. So how easy it is to automate an Android performance test?
There's no such thing as a general Android performance test. So, so the answer would be that it's really easy to get started. Just get the current memory state via ADB command, a single command, really easy to do. So that's really easy. If you want to run actually kind of actionable reports and set up proper monitoring and add it all as part of your CI pipeline, then that's rather complicated, especially if you want to run these tests across different devices and OS versions and so on and so on. So then it gets extremely complicated. So yeah, it can be as complicated as you want to.
Thank you. Yeah, I know from experience also this, going to the black box side, testing everything from a distance is a lot of hacking and tweaking of things. And well, that starts with easy test on one device, and when it gets to those numbers of vendors of Android devices, then it gets complicated. Okay, thank you, Tauno. And now it is going to be my turn, and I'm going to tell you about mobile device battery and data usage testing. So the previous speakers showed you the toolbox of the engineer on a racetrack, when you have your Formula One team racing against others and being able to compete in there. And right now, I would like to distance a bit from this and look at it from a bit of a zoomed out view. And if we would look at those cars from going on street, and that is the way how we actually kind of test the software as a third party. We go a bit from a distance, and we probably can't even step into the car. We don't have access to it. We have this information about how it behaves from a bit of a distance. And here in TestDev Lab, we are doing mobile device battery tests, which are usually a part of, like, there's a complete black box, and it's a part of non-functional testing. So once the software product has checked out all the functional tests, you can start by expanding the test suite with more non-functional tests. And here, it of course requires additional tooling, but also it is supported by, well, applicable to any low voltage device. It's not only a smartphone. It doesn't depend on whatever OS it's running or something like that. It can be used for IoT devices, for instance. Basically anything that runs from 5 to 12 volts. And yeah, and well, about the battery testing, why do we need to do it? So one common usage scenario is to just be able to compare your product against others, and to compare it by using some consumption metrics. And here in these charts, we can see that, for instance, a monitoring over a greater time has been like conducted over almost 2-3 years. And this device is the same, but the app version changes over the time. Of course, these performance tests are not executed that often, so we can do quarterly reviews or monthly reviews, or when a major version comes out with some greater change. So here you can see how it looks when in Q2 of 2019 something was started to be fixed, and then afterwards the battery consumption went down and was quite stable over until very recent. And yeah, we are using real devices. Scenarios are realistic, so those are usually tuned to the use case. We do the same scenario and tend to also automate it on different software, on different apps. And then we can also do the same thing on different variants, configs, versions of the same product. and then we can compare how it looks, and is there something like, was there a result of optimization, improvement, and so on. Of course, we can also see if there was some regression in terms of performance, which is non-functional regression, and also validate the selected hardware design. So if you want to test some kind of new TV box, it doesn't necessarily need to be smartphone. Then also we can do benchmark of devices like that. And yeah, so the testing is conducted with a specific setup. Here you can see in this image below, mobile device, of course, is disassembled. Our engineers attach specific battery, which is, I would say, a hack, so that we have an ideal battery which never goes out. But in the same time, this ideal battery is directly connected to a power monitoring box. We use like almost laboratory grade power monitoring boxes, which in real time provide all the necessary data about the consumption, instant power consumption, and also we can script them and make this automated. Plus, this setup usually consists not only of a battery box, but also some network device that is being scripted to perform poor network. But about that I will talk later. So about battery testing, so here are some popular quality metrics. So we can go with some technical terms, like technical means like ampere hours, milliamps, consuming wattage, consumed amps. But we can also create something like a report how long will this device last on this particular scenario with this particular version of the app. And also we create custom reports where the scenario and also like the results of the measurement are displayed. That here is quite an old example. So here was like a 6-hour test, and we check it against baseline. So first we run the same test without this application or without the problem we introduce externally, and then we compare it with the consumption. How was it with the app or within the scenario or with the problem? And yeah, well, here is how some analysis happens. So not only we collect one number out of all this experiment, but also we can check in time. We can check those samples from the battery box and see like if there is some short event that takes just several seconds, we can trace into that and compare that part of the scenario with other products doing the similar thing. So yeah, and also we can compare different test runs between different scenarios or among like app versions and so on. Yeah, and then I would say this is not that trivial to do by yourself. Of course, you can buy the battery box and hook up the device, but the good thing is that, for instance, in TestDevelop, we have like professionals who can just do it for you. Of course, doing battery tests like this means avoiding the warranty of your device. So I would say that some takeaway would be just to entrust this like this part of performance testing to professionals. Otherwise, we can get to a situation on the right where in one day, 4 devices were, I would say, blown up. Battery is just expanding because the USB hub was configured improperly. So it was working for 2 years. Improper configuration caused all devices to like swollen in a couple of hours. So yeah, and also about battery testing, you can find out how our previous webinar was about it, and we have several quite good reading materials in the blog also about battery testing. So next I'm going to cover the data consumption topic. So here's just one infographic to just emphasize the problem. It's from 2019 Forbes, I guess, showing you how the price looks for the cost of mobile internet around the world looks. So, of course, in Europe, it's not that important. Our prices are quite regulated around 1 to couple of euros per gigabyte, but there are countries especially interested to have less data spent. And of course, that's one thing that we can monitor with data consumption tests. So why should we do it? One thing is, of course, from the business perspective, there can be defined several metrics and so SLAs about the network behavior of the client device or just the software. And also technically applications like gaming, real-time communication and video conference, they can validate various technical aspects when, for instance, validating new codecs architectures, new changes in, you name it, there are a lot of experiments going on, and that all sometimes needs to be checked if it's better or wrong or worse, in terms of new technology. Does it even bring you the improvement, or doesn't it bring you the improvement? So that data consumption testing can help with that. And how it's conducted, it's pretty simple. It starts with some pretty simple setups like, device under the test is connected to a specific network device, like I call it a conditioned router. So usually we use Linux-based network devices, and on those we can run different scripts to cause, for instance, network problems. Use firewalls, IP tables, queues, and QoS, so that all can be applied. And then we can see how much data does this device consume and compare it with, a baseline and different experiments like that. Also, wireless is not the only interface we can do with wired, wireless, or mobile network. Here in Latvia, when we conduct tests, we recently test against 5G internet. So that's a good thing to have in your location. And of course, not only data consumption is being tested, but also the behavior of device under different network configurations. So here we see that we are basically building the racetrack around the car and then running this car in this track, that is very important thing to consider when you want to do these type of measurements. Is to have a controlled environment where you kind of predict it's predictable. You can stably run the tests, and then the connection is quite controllable. And also you can stop problem at any time. And that we do for virtual private networks, network throttling. Also, we do security checks and IP version 4 and IP version 6 testing. Here's one example. I think it was taken from the blog post about the architectures we kind of build in order to, like network architectures, we build to test end-to-end. And there are also other examples in those blog posts. So if you're interested, you can check those out. And network analysis. Well, we start with, for instance, from a distance, we can observe the data through Wireshark. It's very well-known Swiss tool for doing all those things. First of all, we can gather those network consumption statistics per IP address, per port, or per connection. Then we can dive deeper into, analysis of HTTP traffic, or in streaming to do analysis of RTP streams and inspect the packets, collect stats. And also we can do a combination of network throttling or simulate a problem and then see in those network traces how the problem manifests, or is there a problem with the software or the device under the test. And here are some metrics, like for instance, well, I usually don't name metrics. I would say like we define the network profile by several parameters like jitter, bandwidth, packet loss, latency. So in every test, in every experiment, we first declare those and measure those. So we have a precise information of the baseline of the network or the state of the network, and then we can play with these 4 parameters and introduce problems and test more. So in gaming, we, for instance, interested in jitter or latency, packet loss, and bandwidth. Some real-time videos, like jitter and packet loss is quite important. And then, of course, the metrics that we capture or measure can be selected by customer and are very different. Here you can see, for instance, that we can do bitrate comparison of, for instance, several products, several apps, and also all these metrics can be gathered, measured, and measured under network problems. Also, when we go to combinations of tests, here you can see, for instance, that battery consumption can be combined with bitrate, for instance, network measurement. And we can see in combination when a problem happens with the network or with the stream, how it impacts the actual device power consumption. So at the same time, there is a drop in the bitrate, and also something happens with the device current consumption. Sometimes it's the opposite, the spike in current and drop in bitrate. So anomalies like this can be traced by specific analysis of these logs. And lastly, I would like to cover the topic about competitive analysis. So I already we kind of did talk a bit about competitive analysis, so your product against others. Here we can do quite complex setups for the competitive analysis. So we talked about battery network usage, we talked about device resource usage. We can also add to this media quality reports, and all of this happens in a complex scenario or complex setup. So for this, usually test developer finds all these devices, equipment, adapters. So it's usually a rather custom setup. Instead of having, a software as service platform, this usually comes as a package with also setting this whole thing up for you. And yeah, all these above mentioned and other setups can be created in different combinations and also automated. So usually these tests are heavily, largely automated. And then here is one example also for battery testing. So yeah, here we can do some reporting about the expected battery life in hours. So you can see here there is some kind of idle scenario going on, and 5 apps or more are being compared. Your app against 5 competitors, for instance, and we can see how many hours this app can stay there in idle, and if it performs okay against the competitors. Of course, the metrics can be custom and from very technical ones to very busy ones and so on. About competitive analysis, also here you can see that bitrate, power usage, other things can be combined and also compared for different, we're adding another dimension when comparing to competitors. Key takeaways. So first of all, you should keep track of your device power and data consumption. With these custom metrics, you can easily do that. Also, performance testing requires a controlled, stable, and predictable environment, and that is very important, almost the key element in like successful test, performance test. So as I showed you before, we have less moving parts around, so we can focus the context on actually the app and the scenario. And usually those monitorings have same device, same network settings, everything is baseline monitored and so on. Also, there is a possibility to customize the performance testing setup and customize the reporting. Since it's so much customization going on, that's really, a custom offer for every customer. And then we have performance test automation, which is tailored actually to those use cases. Sometimes it's very primitive automation just to cover this, basic scenario of launching this activity or app and then a couple of button presses. Sometimes it involves more complex setups of several devices joining. Like, for instance, we could simulate us joining in the Zoom channel here and then muting or unmuting and doing actions like that, plus getting all those logs and metrics and for the performance report. And of course, yeah, you should evaluate from time to time how your product fares against competition. But also, I would say that it's the same as for other things. Don't need to do it too often, from time to time to keep track of how is it going. Okay, so that's it. Thank you, guys. And now we'll have the time for questions. So, yeah, for more dedicated questions to support, please contact us in info@testdevelop, and please visit our site at testdevelop.com.
Hi guys, my name is Nikolai, and I have a question about iOS. Is there definitely no way to get the black box way of getting performance metrics?
Hey, Nicholas, thanks for the question. So for the black box testing for the iOS, Apple, for security reasons, as I mentioned, prevents connecting the instruments debug tool to these applications, which basically comes from the App Store. And there are some tricky and hacky ways how you could try to recompile it with your own certificate and provisioning profile, but that could easily corrupt the system and half of the application's functionality could just not work anymore. So I would definitely not suggest to do that. And also the measurements could be corrupted then. I would like to say that if you want to try to measure the performance of the application, do that with debug code, which is available for you. Don't try to any hacky ways for the App Store builds. I hope that I answered your question.
Okay, thank you.
All right. Maybe there are some questions, other questions from the audience.
Also, where are you located, guys? Do you have only offices in one country or like in USA as well?
Yeah, we are located in Latvia. We have 5 or 6 offices. The headquarters are in the capital Riga, and in the other bigger cities we have some more offices. And also we have a couple of offices opened in Europe. No one I know that, no office that I know that would be in US.
Okay, thanks.
I have a question about iOS. Basically, when we are testing performance about memory usage and CPU, should we always use activity monitor and then document inspector and then sort by live process and then search for application hour and collect data, or somehow we can else do it? Is it faster way or?
Thanks for the question, Edgar. So if I understood correctly, I would suggest to record the application's performance using the time profiler to the instruments, and then just read the outcome, the results of the test, I don't think there is any other faster way to do that. One thing maybe is you can try to also record all the measurements through the command line. So you can activate the instruments recording option through the command line, do the test on the physical device, for example, and just then stop the recording from the command line, and it will generate specific file which you can later open inside the Xcode, but instruments, and look at all the graphs and measurements which basically the instruments took before, and if you want to compare and get some kind of results out of it. I hope I answered your question.
Yeah, I'll try that one with console.
Yeah, sure.
Hey guys, I have a question regarding the battery testing. Is it like possible to set up any device of your choosing, or are there like some limitations? And if you could clarify, was it possible for both Android and iOS? If so, then yeah, if there are any no-go devices.
Well, yeah, thank you, Kristaps. I think I can answer this question. Well, we use two types of power boxes. One is for regular voltage and one is for higher voltages. And basically, yeah, we can not only work on mobile, like smartphones, but also we can attach some more voltage consuming devices. If I'm not mistaken, also like 12 volts and more can be used. And there is no kind of specific limitation by the OS on that, because that's completely in the hardware. Of course, we need to go through, in our experience, go through the latest devices which show up in the market, and there are sometimes differences with the battery. In one of the slides I showed, like, we had this problem, for instance, all the time we had iPhones with one battery, and starting with iOS, I mean, it was iPhone 10, I guess, which had like 2 batteries. So these type of technical like challenges we face in order to, create this battery setup. And basically we modified the real battery and then proceed with the testing. So it can be any other device, and practically those IoT devices are the latest trend we kind of work with. Yeah.
Okay, thank you.
Hey there. Maybe a bit out of curiosity, but does the performance results actually vary greatly depending on the operation system? I mean, Android 9, 10, or maybe versus Android 5. Does this like influence the whole performance of the application?
Actually, there are two problems, Roman. Thank you for the question. And one problem is, of course, that from version to version of the OS, those baseline results are different. So when executing the same app on a different device, you get that additional or less additional consumption portion from the OS itself. So we usually practice to do like that. We take one version of OS and then run a baseline for it, and then run baseline, this app test, and then take the same device or update the OS, for instance, and then run it again to see, for instance, the baseline of the OS, because that is quite needed. Of course, it influences, and if you want to compare the same result across 2 different models of hardware or 2 different software versions or different OS, that is not quite good practice. Also, we are not mixing up, results from iOS to Android, because those are completely different platforms, and then it gets sometimes confusing that customer, for instance, wants to compare 2 different platforms. but you know, the platform itself is different. And of course, OS version also can be introducing some major changes, even if it runs on the same device. So I hope this answers your question. So in short, we shouldn't do that.
Yeah,
Can I?
Yes.
I'm
Sorry.
sorry, but the actual idea was, for example, we have the application running on Android 9 and it's running smoothly, great. Then the user updates to the Android 10 and then starts the problems. So
Okay.
from this
I can
perspective, yeah.
I can take this one.
Okay.
Yeah, there is a difference. It depends on which APIs your application is using. For some applications, there's no difference, but for example, some APIs, I mean, the Android APIs that your application is calling into, these will behave differently on different OS versions in terms of performance. So it might be that on some Android versions, an API call is really, really fast. On next version, they improved the code or they added more functionality or whatever, and same call might be something that you actually would want to do in a background thread, for example. So there are differences like that, yeah.
Thank you very much.
Yeah. So hope there will be more questions. Well, yeah, that's a, yeah, taking those battery tests is a, you know, it needs to be very, very precise environment. So any changes in the OS layer definitely affect the result. And we usually practice not to compare against versions when OS changes or hardware. So yeah, the only variable, you know, remains when you kind of seat your software in that seat. The only variable should remain is the change that is the software itself, the app.
There is also, speaking of different OS versions, and it can be also that the performance is really, really different compared like on different manufacturer devices, but on the same Android OS version. Because I've seen that on some device, the manufacturer added some logging to an Android method. So whenever your application was calling into it, the OS was actually doing some long running kind of logging requests, and that slowed the application down in some cases. So always be aware of these things and test on everything.
Okay, I think if there is a silence here and no more questions, then we could wrap up the webinar. So thank you everyone for attending. I mean, if someone has a question in the very last moment, please speak out. Other than that, thank you everyone for attendance, and have a great remaining part of the day. And yeah, that's, I guess, it. Maybe Tauno or Maris, some last word?
Thanks for joining in. Thanks for listening. If you have any questions, reach out.
Yeah, thank you guys for listening. Bye-bye.